All right, Spy Master Paul, flying at a constant boom speed, horizontally into a car that has boom this speed. Okay, and it needs to fall 78 meters. So let's see, when we're looking for an angle, so we do need to do some inverse sine, inverse cosine, inverse tangent stuff that falls into the realm of trigonometry, but I think we can handle it. So the first issue is gonna be figuring out how long it's in the air. That's always a good starting point. So if it is dropping, keyword being dropping, that means there's going to be no starting vertical speed. If it's dropping, then we can just do boom. 4.9 is negative, it's dropping down, so that's negative, the negatives go away. We'll be able to get how long this thing is in the air. That's a good start. The next piece is going to be figuring out its catch-up speed. So catch-up speed meaning since these two vehicles are traveling at a different rate, the helicopter is going 215 kph, the car is going 155 kph. So relative to somebody in the car or in the helicopter, the speed between them is 60 kilometers per hour. The difference between the two shows how quickly they're catching up. So if they're going at 60 kilometers per hour, that would turn into meters per second. Always an important step. So I guess I'll change to blue and I'll say we know the time that it's in the air. We know the speed that it's traveling. And in our graph, we've got a vertical distance it needs to travel, but we don't know horizontally how far relative to the ground that this package is going to travel, but we know vertically how far it's going to travel. So if we can come up with this delta x piece, then we'll be able to compare apples and apples. We'll be able to say the package is traveling this many meters horizontally, 78 meters vertically. That gives us two sides of the triangle. So the piece of trig that we might not be too familiar yet, tangent is opposite divided by adjacent. So again, your calculator has all of these values stored. So you're going to take the opposite, which is 78, divided by the horizontal displacement, which you're solving for up here, and you'll come up with some fraction, a ratio, and that ratio you're then going to put in your calculator and say, what angle does that ratio refer to? And that's the inverse tangent function. So you should have a button that says tan -1. Make sure your calculator is in degree mode. And you should get, again, a reasonable angle. If you get something like 8,000, that's weird. If you get something like 0.182, that's probably in radians. So make sure you have something reasonable. Feel free to drop by and see me if you're not sure what reasonable might mean. But okay, so that's, yeah, and you're just looking for that angle. Again, we're comparing distances on this triangle. We can't compare velocities because this vertical velocity is, of course, changing because of gravity. Okay, have a pleasant day.